Hey guys, in this lecture, we will consider quadratic equations. We will also consider some ways and techniques on how to solve the quadratic equations. So, let's get started. A quadratic equation in one variable. This is an equation equivalent in form to ax squared plus bx plus c equals 0, where a, b, and c are real numbers and that a is not equal to 0. So what this one is saying is, if you are given an equation, what we do is to bring all expressions to one side of the equation, say to the left-hand side, and then the right-hand side is just 0. And then if we simplify the expression on the left-hand side, you should end up with ax squared plus bx plus c. If that happens, it means you got a quadratic equation. Now, let us also define what we call an equation quadratic in form. So this one is an equation equivalent in form to au squared plus bu plus c equals 0, where a, b, and c are real numbers with a not equal to 0, and that u is an algebraic expression. Here, it is possible that you don't simply have the variable x, but an expression. So, for example, you can have something like a x plus 1 squared plus bx plus 1 plus c equals 0. So if you look at this, you got x plus 1 here and x plus 1 here. In this equation, your u, this is the expression x plus 1. So we say that this is quadratic in form. Of course, if you expanded this one, so distribute this one, you will end up with the basic form here. There will be also some examples such as you got a times, say, x plus 1 over x minus 1 squared plus b times x plus 1 over x minus 1 plus c equals 0. So this one, your u will be x plus 1 over x minus 1. So this is another example of a quadratic in form. So basically, you got a times something being squared plus b times that same thing, look at this, plus c equals 0. And here we still have a, b, and c to be real numbers and that a is not equal to 0. So you might encounter this type of equation, particularly this type. So basically, the u here can be any expression. You just put it here and here, not just simply your variable x. So most of the time, we will have this expression here, but you will be able to encounter some equations that look something like this, meaning that are quadratic in form. Now, let us find some ways on how to solve these quadratic equations. Let's start with the most basic quadratic equation. Suppose we have p greater than or equal to 0, and that you get the equation x squared equals p. So on the left-hand side, you have something being squared, that's your x squared. On the right-hand side, this is just a constant. Okay, so in here, something being squared, while the other side here, this is a number. To be more precise, positive or equal to 0 number. Number that is greater than or equal to 0. If this is your equation, then your solutions are the following. Your x is equal to square root of p, or that your x equals negative square root of p. So you will get two possible solutions, in fact, two solutions for this equation. In the solution set form, then your set will contain square root of p, comma, negative square root of p. So for instance, let us just look at this example. You got x squared minus 2 equals 0. This one you can write as x squared equals 2. So here, if you look at this, 2 is a positive number. So this means that your x equals square root of 2, comma, x equals negative square root of 2. So these are the solutions for this equation. Similarly, if you got here x squared equals, say, 9, okay, this means that your x equals square root of 9, x equals negative square root of 9, but we know square root of 9, this is equal to 3. So the other one here will be x equals negative 3. As a set, you write it as 3, comma, negative 3. So this one is the solution set for this equation here. Okay? So, like I said, this is the most basic quadratic equation that we can have. Quadratic equation is x squared equals p, where p is a positive number. Then the solutions are x equals square root of p, or x equals negative square root of p. Next, let us look at what we call quadratic formula. So here we consider the equation with real coefficients, quadratic equation particularly, ax squared plus bx plus c equals 0. And of course, we are assuming that a not equal to 0. Note that if a equals 0, then this is not present. You just have bx plus c equals 0, and that's just a linear equation. Okay, so a quadratic equation, it must have a squared term. So ax squared plus bx plus c equals 0. We will look into this number, b squared minus 4ac. If b squared minus 4ac is less than 0, then this equation has no real solution. Again, if b squared minus 4ac is less than 0, then the equation has no real solution. On the other hand, if b squared minus 4ac is greater than or equal to 0, take note, that's a condition, greater than or equal to 0, then the equation has real solutions, which is given by the quadratic formula. The quadratic formula is this one. X equals negative b plus or minus square root of b squared minus 4ac divided by 2a. Again, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Take note that here you got your b squared minus 4ac. The condition is just greater than or equal to 0. If that's the case, you will have solutions. Quadratic formula. So this is something that you need to memorize. You need to know by heart. Now we have been using this particular expression, b squared minus 4ac. It actually has a name. We call it the discriminant of the equation. So this means if the discriminant is less than 0, equation has no solution, no real solution. If discriminant is greater than or equal to 0, then the equation has real solutions. Now notice, if b squared minus 4ac is equal to 0, then the square root of 0 is also equal to 0. So this one will just disappear and you still have a solution. Your x will be negative b over 2a. On the other hand, if b squared minus 4ac is strictly greater than 0, then you will have some square root of some positive number. So you will get those solutions. One will be negative b plus the square root of that discriminant all over 2a. The other solution will be negative b minus square root of that discriminant over 2a. Okay? So let us look at that summary, the discriminant for the quadratic equation ax squared plus bx plus c, where a not equal to 0. If b squared minus 4ac less than 0, then the equation has no real solutions. If b squared minus 4ac is equal to 0, then the equation has a repeated solution. We call it a double root. Because if you go back to this, you got plus or minus. Plus 0, the other one is minus 0, but both of them are just 0. So you will have x equals negative b over 2a twice. One corresponding to plus 0, the other one corresponding to minus 0. So it's the same number, but a repeated solution, or we call it the double root. On the other hand, if b squared minus 4ac is strictly positive, then the equation has two unequal real solutions. One corresponding for the plus or to the plus, the other corresponding to the minus. Okay? Now, there is a third way of solving quadratic equation. This one is by factoring. Of course, if you got ax squared plus bx plus c equals 0, it is possible that this expression here can be written in factored form. In general, you will be able to write this one into the following: a times x minus r1 times x minus r2 equals 0, okay, where r1 and r2 are real numbers. Here we are assuming that b squared minus 4ac is greater than or equal to 0. If it is equal to 0, r1 and r2 will be the same, If it is strictly greater than 0, then R1 and R2 will be different. In any case, if we are able to do this, then this means that the solutions are x equals R1 and x equals R2. So, in general, what I want to say is that if this is easily factorable, you can write it in factored form and you will be able to find the solution easily. Keep in mind that we will be using the zero product property. You got if AB equals 0, then A equals 0 and B equals 0. So if we look at this, A times x minus R1 times x minus R2 equals 0. This means this part here will correspond to this one, while this part here will correspond to this one because of the zero product property. Okay? Now let us look at some examples. So here we have x squared minus 6x equals 7. So what we're gonna do, as I have explained before, we write everything to one side of the equations and then one side of the equation, and then we put the other side equal to 0. So we can write this in the form x squared minus 6x minus 7 equals 0. We'll do this in two ways. First way, solution 1. Let's do this by factoring. If we do by factoring, x squared minus 6x minus 7 equals 0, we can factor this into x minus 7, x plus 1 equals 0. This means from here, we will have x equals 7. From here, we will have x equals negative 1. Okay? Solution set, you got negative 1, comma 7. So that's with the use of factoring. Solution 2, quadratic formula. For the quadratic formula, here, I'll just write it here for details. Your A equals 1, B equals negative 7, negative 6, C equals negative 7, which means X equals negative B, so that's negative of negative 6, plus minus square root of B squared, negative 6, you square that, minus 4, minus 1, minus negative 7, all over 2 times 1. So what's left to do here is just to simplify. Negative of negative 6, that's positive 6, plus or minus square root of negative 6 squared, that's 36. Negative 4 times 1 times negative 7, that's plus 28 all over 2. And then 36 plus 28, that's 64. Let me just write it. Plus 6 plus or minus square root of 64 over 2. But square root of 64, that's 8. So you will have 6 plus or minus 8 over 2. And then you will have, if we take the plus part, we will have 6 plus 8, okay? 6 plus 8, that's 14 over 2. Let me write it. Let me just move this one here. So if we do the plus part, 6 plus 8, that's equal to 14 over 2, comma. If we do the minus part, 6 minus 8, that will be negative 2 over 2. So 14 over 2, that's your 7. Negative 2 over 2, that's your negative 1. So you get the same answers as this. X equals 7, x equals negative 1. So one of them is by factoring. The other solution is by quadratic formula. So it is possible that you will be asked a specific method on how to solve. But if not, it's up to you. You can always do quadratic formula. But if you can factor it easily, then you do your factoring. Next example, we want to solve 10s squared minus 19s minus 15 equals 0. So normally, if we got big numbers, we can just use your quadratic formula. But if you can factor it easily, then you'll be fine. So in here, you got a equals 10, b equals negative 19, c equals negative 15. So x equals negative b, that's negative of negative 19, plus or minus square root of negative 19 squared, minus 4 times 10 times 15, all over, sorry, this should be negative 15, all over 2 times 10. So in here, we will have negative times negative 19, that's positive 19, plus or minus square root 19 squared, that's equal to 361. Then here, we got minus 4 times 10 times negative 15, that will become plus. 4 times 15, that's 60, times 10, that's 600. So plus 600 divided by 2 times 10, that's 20. So in here, we will have 19 plus or minus square root of 961 divided by 20. If you get square root of 961, that's equal to 31. So in here, you will have 19 plus or minus 31 divided by 20. If we take the plus part, 19 plus 31. That will be 50 over 20. If we take the minus part, 19 minus 31, that will be negative 12 over 20. So if we simplify, we will have 5 halves. The other one, negative 3 over 5. So these are the two values. These are the two solutions for this equation. Okay? For our next example, we have 3z squared minus 8z minus 10 equals 0. So let's do quadratic formula again. So here we have a equals 3, b equals negative 8, c equals negative 10. So x equals negative of negative 8 plus or minus square root of negative 8 squared times 4 times 3 times negative 10 all over 2 times 3. So this will be negative of negative 8, that's positive 8, plus or minus square root of negative 8 squared, that's 64. Negative 4 times 3 times negative 10, that will be 120. So plus 120 divided by 6. And you got 64 plus 120, that's 184. Okay, so this will be 8 plus or minus square root of 184. But this 184, this is not a perfect square, meaning there is no integer whose square is 184. Anyway, don't forget the denominator 6. However, we can try to factor 184 into some factors that has, perfect squares. Let's see. So maybe we can use, 184, if we use 8, maybe 16. Let us use 4 first. If we use 4, we will have 4, and then the other one is 6. 4 times 46, that's 24, carry to 180, 184, yeah. For 46, we will have, say, 2, and then 23, 2 times 23. So we can just factor 184 into this 4 times 46 because these two here, they don't contain any perfect square. So this means that you can have 8 plus or minus square root of 4 times 46 all over 6, which can be simplified into 8 plus or minus 2 square root of 46 over 6. Simplifying further, we will have divided by 2 in everything. We will have 4 plus or minus square root of 46 divided by 3. So you can write the final answer in this form. You don't have to separate the plus part or the minus part. So you have x equals 4 plus or minus square root of 46 over 3. Okay? Next example. Of course, as usual, we will have some word problems. So for this one, we got the area of a rectangular window is to be 399 square centimeters. If the length exceeds the width by 2 centimeters, what are the dimensions? So for this one, we can say let L be the length and W be the width. Then length times W, it said the area has to be 399 and the area is length times width. But in here it said that the length exceeds the width by 2 centimeters. So also you will have your L. This is equal to W plus 2 because the length exceeds the width by 2 centimeters. So this means we will have W plus 2 times W equals 399. Then we just solve this equation. We have W squared plus 2W equals 399, or that W squared plus 2W minus 399 equals 0. This is a very big number, okay? But you can factor this out. I think it's possible to factor this out. So 399, I think this is 19 times 21. Yep. So if we do factoring, this will be W. So 399, let me just write this. 19 times 21, this is 399. But since we have a negative here, one must be a positive, one of this must be positive, one must be negative. And since the middle part is positive, the bigger number is the positive. So W plus 21 times W minus 19, this is equal to 0. So from this part here, it says W equals negative 21. From this part here, it says W equals 19. But we are talking about lengths or width. So we can only take positive. Since W is a width, W equals, or W cannot be negative. Can't be negative. So W equals 19. Which means L equals 19 plus 2 equals 21. So these are the dimensions. W or width equals 19 and length equals 21. And let us just put the units, centimeters, centimeters here. Okay. Next problem. An open box is to be constructed from a square piece of cardboard by removing a square of side 4 inches from each corner and turning up the edges. If the box is to hold 576 cubic inches, what should be the dimensions of the cardboard? Let us analyze this. So you got a cardboard, and then you are going to remove squares on the four corners of the cardboard of side 4 inches. So let us say this is your square, square, square here, then square here. So you will cut them, and this will become something like this. So it will look like this. And then you will fold along this one here, this one here, this one here, and then this one here to make an open box. So the question here is, what should be the length or the dimension or dimensions of the cardboard? So question mark. So let's start with the length. Let L be the side length of the cardboard. Take note, the cardboard is a square, so everything will be L. The whole thing here, this is L, this is also L. After cutting the square pieces here, after cutting this part here, this part here, this part here, this part here, this here is equal to L minus 8, because this one is 4 inches, which means this is 4 inches. This is also 4 inches, which means this is 4 inches. So you remove 8 inches. Similarly, this is 4 inches, 4 inches. So this part here is also L minus 8. That will be the base of your box. The height after folding this up, after folding this part, this one up there, up there, up there, the height is this part here. Correct? This part here. And that's equal to 4. That's 4 inches. That's the one, this part here. Oops. This part here. So the volume of the open box is 4 times L minus 8 times L minus 8. And it's said it must hold 576 cubic inches. So this must be equal to 576. Now if you look at this, L minus 8 times L minus 8, that's just L minus 8 squared. And if we divide everything by 4, this will be equal to 576 divided by 4. And 576 divided by 4, that's equal to 144. Now, if you look at this, something being squared equals a number. Again, something being squared equals a number. This means that L minus 8, this is plus or minus square root of 144. But square root of 144, that's just equal to 12. So L minus 8, this is equal to plus or minus 12. Which means L, this is equal to plus or minus 12. We bring this to the other side, this becomes plus 8. So this means that L is either 12 plus 8, which is 20, or the other one is minus 12 plus 8, that's minus 4. But then again, L is a side length. So we can only take the positive solution. So this means you got, so therefore, let me just write the conclusion over here. This means that L must be equal to 20 inches. So the dimension is 20 by 20. Dimension of cardboard is 20 inches by 20 inches. So that solves the word problem. Okay? Let us look at some more examples here. So we have x minus 5 squared equals 2x. Now observe, we have something being squared, but the right-hand side involves a variable. So take note of that. You cannot just take the square root of the right-hand side because it involves variables. So to do this, we have to simplify first. We expand this left-hand side. Expanding that left-hand side, we will have x squared minus 10x plus 25. The right-hand side is equal to 2x. And then we solve. We put everything on one side of the equation. Let us put them to the left-hand side. We will have x squared minus 12x plus 25 equals 0. Then we can solve this equation, quadratic formula. So in here you got A equals 1, B equals negative 12, C equals 25. 25. Okay, so X equals negative of negative B plus or minus square root of B squared. Oops, I should write negative 12, but that's B squared minus 4AC all over 2A. And then negative 12, that's positive 12, plus or minus square root of negative 12 squared, that's 144. 4 times 25, that's 100, so minus 100 all over 2. 144 minus 100, that's 44. So 12 plus or minus square root of 44 over 2. And note 44, this is equal to 4 times 11. So we can write this one as 12 plus or minus 2 square root of 11. Square root of 4 is 2. 11 stays inside. And then you got over 2. Simplifying, we will have 6 plus or minus square root of 11. So this is the solutions. These are the solutions to this equation. X minus 5 squared equals 2x. Again, you have to make sure you get something being squared here. Right hand side, it has a variable. So you cannot just do the square root thing. If this were just a number, then we can do that, just like in the previous example. Something being squared equals a number. So something being squared equals a number. That's why we can do this one here. Here we cannot do that. Next example here, we got x plus 2 times 2x minus 1 equals x squared minus 1. So of course, the first job is just to simplify everything. We expand this multiplication, and then later we will bring this to the other side and simplify. Expanding, we will have 2x squared minus x plus 4x minus 2 equals x squared minus 1. And then we bring this to that side, 2x minus x squared, that will be x squared. We simplify this, plus 3x. This one we bring to this side. This will be minus 2 plus 1. So this will be minus 1 equals 0. So quadratic formula, x equals negative b plus or minus square root of b squared. So 3 squared minus 4 times 1 is negative 1 all over 2 times 1. So in here, you got your a equals 1, b equals 3, c equals negative 1. So you don't have to write every time this here. can do that mentally. But as a guide, you can always do that, so you won't get lost. So anyway, we will have here -3 plus or minus square root of b squared, that's 9. 4 times -1, that's plus 4 over 2. So simplifying, we'll just have -3 plus or minus square root of 13 over 2. And square root of 13, you cannot um, factor it anymore into something that has a perfect square. So that will be the final answer. Next problem here. As usual, we do the same as in the previous example. We expand this. We write this to the other side. So if we do this, we will have x cubed plus 2x squared. So x cubed, this one to this one, 2x squared, this one to this one, minus x minus 2 equals x cubed minus 4. So notice here, this x cubed will cancel this x cubed. And then if we bring this to the other side, we will have 2x squared minus x, and this one to the other side becomes plus 4, so 4 minus 2, that's plus 2, equals 0. Now, if you look at this, a equals 2, b equals -1, c equals 2. If we check b squared minus 4ac, b squared, that's -1 squared, minus 4 times 2 times 2, this will be 1, minus 16, this is -15. It's a negative number, which means that this has no solution, has no real, take note of that, real solutions. So that is our conclusion. Finally, here we got x cubed minus 6x squared plus 7x equals 0. If you look at this left-hand side, you can easily see that x can be factored out. So we can have x times x squared minus 6x plus 7. This is equal to 0. Furthermore, you can check this one here. This is not factorable, but let us see. This one here, from this part, it means x equals 0. From this part, it means x squared minus 6x plus 7 equals 0. So this is a quadratic equation. We can do quadratic formula as well. If it has a value, I think it will have. Anyway, x equals negative of -6 plus or minus square root of b squared, -6 squared times 4 times A times C all over 2 times 1. So we will have 6 plus or minus square root of negative 6 squared. This is 36. 4 times 7, that's minus 28. Yep, all over 2. Or we will have 6 plus or minus square root of 8 over 2. Square root of 8 is 2 square root of 2. So you will have 6 plus or minus 2 square root of 2 over 2. Or that, simplifying, we will have 3 plus or minus square root of 2. So here, we actually have 3 solutions. This and this. So x equals 0, 3 plus square root of 2, and 3 minus square root of 2. Okay? So as a last remark, just try to practice on the exercises that we have in our module. So that's all from me for this lecture, and see you in the next one.